Hey guys, this is Matt Core from CtrlPaint.com, and I'm really excited about this series. This is a very fundamental skill that is going to build on what you've done with Basic Rendering 1, but now we're going to take it into a different direction. Because in the previous series we talked about rendering simple matte surface objects with a simple lighting setup. And for a variety of reasons, I really think this is the core of your ability to render. Because on this foundation, you're going to be able to advance to complicated forms, complicated lighting, complicated materials. The only problem though is that so far we've really only talked about doing this from direct observation. Whether you're using a photo or looking at a physical object, those skills are only going to get you so far in terms of illustration. And we need to be able to do all of these same techniques from our imagination. This tanker truck here is a great example of our goal. Now, you don't need to be really concerned about the complexity of this shape. Don't let that scare you off. Because over the course of this series, I'm going to explain how you can render any form, simple or complicated, following really just a few guidelines. Using these guidelines, you'll be able to take your line drawing, imagine a light source, and then render the form. So for the sake of consistency, we're going to be mainly using a similar lighting setup to the one from Basic Rendering 1. It's going to be strong directional light. And then we're going to have a little bit of bounce light filling back in that shadow detail. And since we devoted so much of the last series to talking about how to use the tools, as in how to use Photoshop to blend paint and those sorts of things, in this series we're going to skip the technical talk. For the sake of this series, I'm just going to assume that you either know the basics of digital rendering from elsewhere, or that you've watched the previous series called Basic Photoshop Rendering. And I should also mention that these techniques are totally software agnostic. So if you want to work with GIMP or Sai or Painter, or really even traditional media, these techniques are exactly the same. All we're doing is talking about theory. So before we get into specific examples, I just want to show you how short the list really is when it comes to these general rules. So in brief, we have a shadow shape, which consists of a form shadow and a cast shadow. And then where this ends and the illuminated form begins is called the terminator. The cast shadow and the form shadow are not sort of a uniform black. They have a little more detail than that, and that's because there is bounce light filling that detail back in. But it's really these key landmarks that we want. We're looking for the terminator, the edge of the cast shadow, and the form shadow. Because if we can find these key landmarks on a simple form like this one, they are found in the exact same way on complicated shapes. And then when you make a complicated rendering like this one, you're really just doing the same few things over and over. So let's see how we find these crucial landmarks if we don't have reference. So first we're going to need to know the light direction. And for these examples, I'm just going to assume that the rays of light are parallel and far away. So this is like if we had the sun or potentially a very bright spotlight. So the simple, crucial rule that drives this entire process is light angle. So what I'm going to do is I'm going to compare the angle of the light to the angle of the surface that it hits. And when you compare those two together, you know something about the illumination. If this angle is very perpendicular, you get a very bright surface. This is where it's the most illuminated. If it is very parallel, then the rays don't even hit the surface, they just pass straight on by, and as a result it's very dark. Now all of these angles in between here are going to make sort of a gradation of values across the surface of your form, going from dark to the most illuminated where it's the most perpendicular. Another way of saying this is where the light is most tangent to the form. But moving our way back down away from where it's most tangent, at some point you'll hit this area where the light is totally parallel with your surface. And this is called the terminator. This is the beginning of your shadow shape. Everything beyond this point is going to be darkness, or darkness that is filled back in with some bounce light. And the reason for this is because beyond this point, the directional light can't reach your object. And as you know, I love working from simple to complicated. And a great way to apply that notion to light angle is by simplifying the form. So instead of this being a perfect sphere, let's imagine for a second that the profile was a segmented, faceted surface. A quick way to think about this light angle is to imagine little arrows pointing off the centers of these faces. And you'll notice that these arrows here are perpendicular to the surface direction. And then here I have my light direction. And what I'm going to do is I'm going to compare the light direction to some of these surface arrows. So if I were to compare it to this one right here, you can see that they point directly at one another. And that means that this is where it is the brightest. If I were to move it here to the next one, you can see the angle they create is a little bit bigger. Moving it down to this next one here, the angle gets bigger still. And if I keep doing that, eventually I'll get to where the terminator is, and you can see what is created here as a 90-degree angle, because the light just keeps on moving and does not hit the form anywhere down here. So when you're thinking about form, imagine these arrows. You'll begin to just have a sort of a mental reaction to when you see the bright area of the form. Well, that means it's sort of looking straight back at the light direction. If it's a little dimmer, the arrow is not looking right at the light direction, it's looking somewhere else. So you can use this as sort of like a little mental trick to quickly determine what is the light angle. Because it doesn't need to be perfect, we're not doing math here. It's really just a rule to guide your imagination. Okay, so what about the cast shadow? How do we know where that gets projected? Well, the way you find the cast shadow is by drawing little imaginary lines from the terminator in the direction of the light, and then you just keep drawing that line until it collides with something. And in this case, what we're going to collide with is the ground plane. So if that's one point, I can just repeat that process a few different times, and I get sort of a connect the dots. And then when I make a shape from those dots, that's my cast shadow. It's really pretty simple. So the general sequence goes, you know where the light is. From that, you can figure out where the light becomes parallel to the form. That gives you the location of your terminator. Everything beyond the terminator is shadow. It's either a form shadow or it's a cast shadow. And the way you figure out where the cast shadow is by projecting some quick lines from the edge of the terminator to the ground plane. And that's it. Really, theoretically, at this point, you could turn the series off because those are the only major rules that allow me to render either a simple form or a complicated one like this. Now, seriously though, I'm going to break these rules down into sort of common forms and real-world scenarios that'll just help you familiarize yourself with the results. But this is all about practice. So we're going to go over these in detail, as well as some homework assignments that are included with the series. So to find those, make sure to look in the resources folder. Then you can follow along with the videos and then do some exercises yourself. All right, without further ado, let's go ahead and get into shadow casting and finding the terminator. So far we've looked at one example, and the example is the classic sphere. But it is the same rule set that works on any shape. So in this video, I'm going to go through simple and then increasingly complicated examples to show how these same rules apply in different scenarios. And when I was learning this stuff, it really only started making sense when I saw it repeated over and over. So hopefully that's what this video is going to do. Just going to show you it through enough different repetitions that it'll start to sink in. So let's talk about how we would approach something like this rectangle here. This is not a sphere, so it's going to be a little different than that last diagram we discussed. But the fact is, you still have a terminator. This is the point at which you go from light to dark. And here it's just going to be these faces of the cube that are not facing the light source. So if we can say this is our terminator, then we need to be able to determine where is the cast shadow. Because really, I think a great first step in this whole process is to be able to cast your shadow. Really, to do this, we only need a few landmarks. We need to know these corners and to be able to project them down onto the ground plane. And then all you have to do is connect the dots and you get the shadow shape. Now, if this seems immediately too challenging for you, my guess is it means you don't have a great grasp on linear perspective. Now, in the store, there's a series all about linear perspective, and I wouldn't exclusively call this a prerequisite, but it's definitely going to help, because a lot of this drawing from your imagination really does rely on perspective. So here in this case, I was able to imagine where the ground plane was in order to know how far to project these lines. And if you can't really picture the ground plane, then you can't do this step. So once you've filled in this shape, then you might add a little bounce light back into the cube, but really that's just polish. The crucial first step here is to be able to identify where's the terminator. In this case, it's a pretty straight, obvious line, and that's based on the light angle. And then once you've found the terminator, you extend some points, and then you have your shadow shape. Okay, this next example does not have any corners, so how do we know where to cast our shadow from? Well, first let's think about it in terms of a top view. And if we picture this from straight down, it becomes a little bit like that sphere. So based on the light angle, we know that the very front of this cylinder is going to be the brightest. Then it's going to get dimmer and dimmer and dimmer as it rolls away across the form. And then here at the apex, we have the terminator. So the back half of this cylinder is essentially totally in shadow. Well, I'm going to draw that in my form here on 3D space. And now, once again, I need to know where the ground plane is, and this is where linear perspective comes into play. But then once I do that, I can just pull some lines that are parallel to the light direction, and then just find a few points on the edge of the terminator. And all I do is intersect those lines parallel to the light source from the terminator to the ground plane. And then I just have a connect the dots down here. So I'll pull lines that start from the terminator at the bottom of the object, and then pull towards those new points that I found on the ground plane. And then at this point, I know that those sort of 3 points that I projected are going to end in a rounded top because this is a cylinder. And then I can just erase away all those guidelines that I had because I don't really need those anymore at this point. And then it's just a matter of filling in the shadow shape. And if I want to, I can go ahead and add a little polish. So you could think of it as a totally black shadow shape for simplicity, or here I'm sort of rounding out the form and adding a little bit of reflected light back in. But again, this is just polish. The crucial thing to understand here is, can you look at the angle of the light, figure out how to project a cast shadow from the edge of the terminator onto the ground plane. Okay, let's go ahead and do the same thing here, but this time we're going to do a sphere that is not perpendicular to the camera. So really the crucial thing here is to figure out where is that terminator. And the way I like to think about it is almost like a cross section. Again, this is a bit of linear perspective, but what I'm doing is envisioning a disk that would be almost like the equator of this object. Now, unlike the Earth, this is not the equator that's perfectly horizontal. Here it is an equator that is pointing exactly at the light source. Now, this is not physically in your object. As you see here, I'm erasing that back of the object, But what that cross section gives me is the shape of the Terminator. Because really all we're doing here is the exact same thing as the side view that we thought of before. The light angle comes in at one direction, and then essentially 90 degrees to that direction is going to tell us where our Terminator is. So you're envisioning this diagram, we just happen to be doing it in three-dimensional space. So again, this is where understanding linear perspective is just going to help you imagine this a little bit more easily. But then once we've determined where the Terminator is, we can fill in everything below it, and that gives us our form shadow. And here I've sort of softened up that transition a little bit, but you could leave it as razor sharp as you want. That's really just a question of what kind of light source is casting the shadow. Now I take some parallel lines and pull them from the edge of the Terminator, and then I'm going to throw in sort of a quick ground plane just so I can help visualize this a little bit better. And then I will connect the points where those parallel lines connect with the ground plane, refine it a little bit, and this is going to give me the shape of my shadow. So once again, how I decide to fill in the shadow and how much I want to refine afterwards is not as important right now. The important part is being able to visualize that set of parallel lines that go from the edge of the Terminator and then intersect with the ground plane. This is a little hard to wrap your head around at first, but it is just the crucial thing to make this technique work. Because the rendering part, that's easy. You know how to mix paint, you know how to make careful edges, but what you may not know how to do is place a shadow. And all the rendering in the world is not going to fix a incorrectly placed shadow. But speaking of which, when I sort of resolve this at the end here, I recognize that my Terminator is actually a little bit low. And so in the sort of polished rendering I do here, I raise it up a bit, and then it squares better with my cast shadow. All right, let's go ahead and try this one more time with the cylindrical pole. This time we've got a little different direction for the light source, so the shadow is going to be cast backwards into the distance. So the first step in trying to figure out how to project my cast shadow is deciding where my Terminator is. And here in the little diagram I've included in the top view, you can see that the Terminator here is only going to really be visible on one side of the form. But once you find where that Terminator is, just start pulling lines on the ground plane, erase away what you don't need, and then we're going to connect those lines from the parallel lines at the top of the form. You know, and this is a real world thing that you can observe. If you go outside on a sunny day and there's a telephone pole casting a shadow onto the road, you can look at where is the end of the cast shadow and then draw an imaginary line to the tip of the telephone pole. And then if you just keep extending that line, eventually you'll hit the sun. So this is not some arbitrary rule. This is just how light works in the real world. And then of course the rendering part here is pretty self-explanatory. You erase away your guides, you fill in the cast shadow and the form shadow. And then if you want to lighten up the form shadow a little bit to represent bounced light, that's fine. Again, this polished stuff I'll leave to your own devices. I'm just going to show a little bit here, but the really important part is finding that Terminator and then correctly projecting the cast shadow. Okay, hopefully this is starting to sink in a little bit. So let's take the difficulty up one level, and instead of having a ground plane to cast a shadow on, we're going to have another object. So in this case, we have a floating cylinder casting a shadow straight down onto a cube and a ground plane. Now this might be a little harder to see in the real world, although think of anything. Think of power lines hanging over the road. Same deal. So just like before, the first step is going to be find the Terminator on the cylinder. Now in this case, the light is coming from absolutely straight overhead as if it were noon. So the Terminator is going to be about halfway down the form. The top half's going to be light, the bottom half's going to be dark. And this is going to give us the edge from which we are going to pull these vertical lines. Now, in this case, vertical lines are parallel to the light source. So as you're pulling these lines straight down, you're going to have to know where is the ground plane. Again, this is sort of a linear perspective thing, but where they hit the ground is going to be the edge of the cast shadow. And then we'll just begin to extend these lines as if they were following along the surface. So it will extend on the ground plane until it hits the cube, and then it's going to go straight up the face of the cube. And then at this point, it will go across the top of the cube, staying sort of parallel with the lines of the cube. And then to figure out where it extends to beyond the cube, I'll just pull some sort of parallel lines along the ground plane, and then drop my projection line straight down from the edge of the Terminator to find that intersection. So here I've got my cast shadow shape. I mean, how cool is that? I did not have to look at any reference. All I did was follow a few rules, understand a little bit about perspective, and I can cast a realistic imaginary shadow on an imaginary box. I just think that's awesome. Again, the rest of the polish you do beyond this point is totally up to you, but figuring out where to project that shadow, that's the tricky part. Okay, got that? Well, let's take it up one step more difficult. Now, really, the rule here is that shadows do not multiply together. When you have two different shadows, in this case, a rectangle casting a shadow on top of a sphere, and the sphere has its own form shadow, those two just sort of get welded together and make a single shape. But a cast shadow is generally going to have a harder edge, but a form shadow like this sphere is probably going to have a softer transition. So the end result here of the two added together is a sharp edge and a soft edge. So the way I like to do these generally is to start by rendering the form shadow on the sphere here. And that is going to remain untouched by the next results I do. Everything else is going to be added to that. So now it's a matter of pulling lines parallel to the light source to project my shadow edges. And since this is a nice rectangle, I can just pull them from the four corners, intersect them with the ground plane, and erase the extras. And so once again, here I have the cast shadow shape on the ground. But now the question is, well, where is the cast shadow on the sphere? And just like in a previous example, this is all a matter of being able to picture a cross section, being able to imagine a contour line being drawn across the surface of this form, almost like a longitude or latitude line on a globe. And it's just going to be where does the shadow edge intersect with the surface of the sphere, and then draw one of those lines around the edge. And if you get that contour incorrect, it's going to mess with the perception of the sphere's form. The cast shadow edge here is really going to help explain the shape of the sphere, so getting it right is pretty important. And then you've got your shadow shape. So you're going to fill in the cast shadow pretty flat. And then here I just want to make sure the values are going to match up between the old form shadow I had on the sphere with the new cast shadow from the rectangle. But the results you see here are something you're going to start seeing a lot of, which is a hard cast shadow transitioning into a soft form shadow. So let's go ahead and try a similar example here. We have the cube from before, and we're going to go ahead and add in a cylinder laying next to it on the ground. And the way I like to think about this first is, well, what is the form shadow going to be on the cylinder? Because no matter what shadow gets cast on top of a form shadow, you always have a form shadow. So for me, that's a great place to start. So I'll start by thinking about where is the terminator. Again, this is where the light becomes parallel to the surface, and I'll draw a line there. And then this is really that crucial thing. Once I know where the terminator is, I know that everything below it is form shadow. And then I'm also going to know how to project that cast shadow from the edge of the terminator. So for me, the sort of rendering shorthand for this is fill it all in with a solid tone as if there were no bounce light at all. And then think about where there's going to be bounce light. And then I'm going to put in a little bit of an occlusion shadow down here where it's sort of the deepest crevice. So that's going to be a little bit darker than the rest of the cast shadow. But really, at this point, this is just being sort of fussy because you'll notice that I have not yet included a crucial piece, which is the cast shadow from the rectangle that is being cast on top of the cylinder. Because really, the form shadow is almost separate from the cast shadow. So I can go ahead and do the form shadow all the way first, and then do my cast shadow. So just like before, I'm going to go from the corners here, because that's the terminator, and project parallel to the light direction. And then when it intersects with this cylinder, it is going to sort of curve around the contour. So once again, this involves me sort of imagining cross sections of the cylinder to help guide the way that I draw this projected cast shadow. If I get this contour wrong, it's really going to mess up the form. But if I get it right, it's going to help really accentuate the shape of the cylinder. And then once I've traced my outlines, I can go ahead and fill it in, and the rest is pretty basic. All right, next we are going to take a look at a compound object. Because the world is not made of primitives, there are sometimes objects that have sort of two shapes welded together. And in this case, we have a simple sphere with a disc protruding from the top. And let's take a look at what we've got here before we go ahead and create it ourselves. We have a standard rendering as if you'd imagine the normal sphere, but then the disc has its own terminator, it has its own mini form shadow, and it also is casting a small shadow. So the way I'd approach this would be just like before. I'd start with the terminator, I'd fill in the form shadow, and then I would project my cast shadow. Although in this case, it's casting a shadow on itself. It doesn't even get near the ground plane because it's such a short disc. But the rules are all the same. In this case, you can think of the sphere as the ground plane. So to continue this thought experiment, what if instead of a disc, it was actually a tall rod that was extending out of the sphere? My first step would be to add the terminator, which here is just like rendering a normal cylinder. And then once I have a general sense of where the terminator is, it becomes a question of where is the cast shadow. Now before with the disc, the cast shadow was very small. But now, since this rod is much longer, the cast shadow is also going to be much longer. So first off, I am going to pull some lines along the form of the sphere. Again, this is like imagining longitude or latitude lines. You're just drawing contours of the object. And then I can fill that in with a flat value because this is the hard-edged cast shadow. But in this case, it is going to be long enough that it actually extends off of the form and onto the ground plane. So to figure out where that is exactly, once again, I'll just draw lines that are parallel to the light source, starting at the terminator and then intersecting with the ground plane. So as you're starting to see here, I'm just doing the same rules over and over in different combinations. What starts to happen is you'll be able to look at a form and sort of break it down into geometric shapes in your mind's eye. And then you'll start to see, where is a hard edge? Well, that's probably because it's a cast shadow. Where's a soft edge? Well, that might be where a form shadow is showing that a surface is rounding around in space and turning away from the light source. But I gotta say, graphically, cast shadows are really great. Here in this example, you can see that a chair just gives you more information when you can look at its cast shadow. It's almost like getting a second view of the object in a single image. Your brain really just does a great job putting together that information to give you a fuller picture. Another great example would be if you had something like this sort of flat, generic, bumpy outdoor scene, like a field with rocks in it. But then if you put a bridge over this gap, all of a sudden the cast shadow tells you a lot about that field. You get almost like a cross contour line just drawn from that shadow that gives you a great sense of shape. Now the ground that had sort of ambiguous bumps before has a really clear contour. Another time cast shadows are useful is when you're looking from a sort of high camera angle and you can't see much of an object. All of a sudden the cast shadow tells you a lot more about the object's form than the form itself. Of course, in an example like this, the time of day does matter. This same shot at high noon would not give you much info. So we can agree that cast shadows are very important. They really help set the scene and help explain form. But the learning curve can be kind of challenging to figure out how to project these yourself. But I kind of like this stuff because it gives you almost a formula to just render out a scene based on simple rules. So by now, the homework for this chapter should come as no surprise. I'm going to give you a very straightforward light, which is a directional light just like these examples. I'm also going to include the form, and I've also included a ground plane if you're having trouble picturing the sort of ground grid. But what you're supposed to do here is to fill in the form shadow and the cast shadow. Now, as far as how you render the shadow, well, that's up to you. If you don't want to do any reflected light, it doesn't matter to me. Really, it's a question of can you find the terminator? Can you project the cast shadow? Good luck with this. This is tough, but it is really going to improve your drawing. Okay, so far we have figured out how to make the cast shadow and the form shadow. And if this is all you ever knew how to do, you'd end up with sort of a Frank Miller, Sin City graphic abstraction. And that's cool, but it's not really realistic rendering. What we want to do is describe the form. And the way we're going to do that is by using value gradation across the illuminated part of the form. And when you see this, it just tells your brain what the shape is. So really, value is form. Because when you look at these two very similar objects, you know immediately this one has a sharper corner and one has a rounder corner. And the only indication of that is how quickly I transition the value from light to dark. Because in one case it's sort of a curved surface and the other one it is a very angular surface. And your brain immediately figured that out based on the rendering. So that's what we have to figure out how to do, how to communicate to the viewer the shape of our object using value. No problem. So here you can see that sort of planar abstraction. And one way that you could blend between these planes to smooth it out would be to use on-screen mixing. That's the way I normally paint. But another way would be to take those same planes and instead of using the brush tool, to go ahead and use the smudge tool. And depending on how you set it up, it gives a very nice blending look to smooth out that value transition. And if you want to know more about this, I've actually released a couple videos recently in the free library that have included tool presets for the smudge tool, as well as some technique overview. So head over to the free library and check that out. The practical example of this would be back to the very early video in which I talked about doing an apple rendering, first as planes, and then mixing between the planes. Well, if you don't want to use the brush tool, using the smudge brush is sometimes a nice alternative. So here I'm just changing the brush diameter, but I'm really not doing any sampling. It's doing that mixing automatically based on the way the smudge tool is set up. But anyway, that's technical stuff. That's besides the point in this series. What we're going to be doing is making careful value transitions, and the tools that you decide to use for this task are really up to you. In fact, I hope there's somebody out there using charcoal along with this video. That would just be great. So what we're going to do here is look at some very basic planar changes and think about how the light is going to react to that surface. So if we just had a totally flat surface and sunlight, we would have one value. For as far as you can see, there's always going to be the same angle between the flat plane of the ground and the angle of the sun. Well, if we had two planes that were at right angles to each other, they would have two values because each one has a different angle relative to the sun. Well, sometimes you're actually going to have pairs of angles, as in pairs of values. So a stair set is a great example of this. You'll notice that the front faces here are all being illuminated in the same way because directional light is pointing at them with equal intensity. You'll also see the top faces are all the same values one another. Same deal. They are pairs of angles, which means they have pairs of values. Okay, let's go back to our simple single ground plane scenario. But let's take a look here if we made a tunnel in that ground. So if you look at it in side view, let's envision those little arrows that point off the surface. The one that's going to be pointing most directly at the light source is this one over here on the right side. So when I render my form, that is going to be the brightest value. With that in mind, I've actually rendered the ground plane as sort of a middle gray, knowing that I need to reserve some brighter values for where it's actually the brightest. Because a really common mistake is to just make the top surfaces of things the brightest. But that's not necessarily the right way to do it most of the time. And then if you can imagine the light angle of the opposite sides of this tunnel, they are going to be a little bit darker. Now, because of the angle of the camera, you can't see that side very well, but just know that you're going to have a relatively darker value on the opposite side, because this is sort of like an inside-out sphere. And then if you want to go ahead and polish it, totally fine. Again, that's totally up to you. The important thing to remember here is that the brightest value is the surface that's pointing most directly at the sun. And if you're just starting out, your intuitive guess might be wrong. Okay, with this next example, we are going to keep everything the same, except instead of a tunnel, it's like a hill. So let's think about this in the side view. We're going to do our little diagram again. So we have the light direction coming in from this angle, and we're going to compare that to the various little arrows pointing off of the surfaces. And we can immediately tell that this part of the cylinder is where it's going to be the brightest, and then it's going to fall off from there. And then eventually at the very back, there's also going to be a terminator here and a bit of a cast shadow. So when we make our rendering, it's pretty straightforward. The ground plane is going to stay one value. It's going to be a relatively brighter value where the hill is pointing most directly at the sun. And then it's going to be a darker value as it rolls down the form towards the ground plane. Because if you think about it, the sides of that hill are really not pointing towards the sun at all. They're pointing a lot further away from the sun than the ground plane is. So it's going to be a little bit darker. And then I've also included the cast shadow, which is almost invisible based on this camera angle. But you remember, based on where the terminator is, the last little bit of that hill is indeed in shadow. All right, next up, we are going to do a little divot in the ground. So here, instead of having a tunnel, which is like a cylinder, this is as if you put a golf ball in the snow and then remove the golf ball. So here with our diagram, we can judge some relative values. We have the brightest angle right here. So that's going to be our brightest value. And then we have some sort of in-between values around the edge. And then notice that we do have a terminator here and a little bit of a cast shadow. Now, again, because our camera is placed where it is, you're not going to see a whole lot of that cast shadow. But when we do our rendering, that area will just need to be a little bit darker. So for the rendering, we'll start with the ground plane being a value that is not the brightest. And then I'm going to go ahead and darken down inside the divot. But then after that, it is important to put in that bright value. And this is almost like you're rendering a sphere. It's sort of like an inside-out sphere. So the brightest area is going to be circular. It's not going to be a band like in our last example with the tunnel. And when I do this polish, I like to average things out. I have a tendency to make things too high contrast. And when you're working with matte finish objects, they actually have a very subtle value transition. Anytime you have too high of a contrast, it starts to indicate that the surface is shinier or glossier, and that's not what we're working with for this series. You know, you can think of a matte finish surface as a clay model, or a car with primer but no paint. And then of course you're going to see a little bit of that darkness around the closer lip, as we saw in our side diagram. That's where the cast shadow is. But predominantly from this angle, what you're really seeing is that illuminated area in the bottom of the divot. So the next example we've got here is the opposite. It is a little hill peeking out from the ground plane. You could think of this as like a small sphere that is protruding just a little bit, not even half of a sphere. And when we look at the side diagram, we can see a few things. We have a very familiar hot spot here where it's pointing most directly at the sun angle. And then we follow that around until the light rays are parallel with the surface. That's where our terminator is. And so the last little bit of this hill is going to be in shadow. And ever so slightly, it would do a cast shadow, although that's not going to be terribly visible. We'll just indicate it as a bit of a form shadow on the reverse side of the hill. But the rendering goes just like before. In fact, I'm going to leave the ground plane the exact same value that it was, and all I need is a relatively brighter value to mark in that highlight. So what we start to understand is that plane change means value change. Value change means form change. And then the question is, well, how much is it changing? When you look at a simplified head here, you can see there's some soft transitions, which is a longer gradation. And then there's some sharper transitions, which have a much quicker transfer from light to dark. And immediately you know something about the form. You know that where there's a sharp change in value, there's a sharp change in the form. So now we are sculpting, if you really want to think about it that way. And the values that we lay down are going to tell about the surface that the viewer is looking at. So let's make our object a little more complicated, and this time it's going to have a more interesting profile. First, you can see it's got almost like a quarter of a cylinder. And then when that finishes, it becomes a flat board, which is parallel with the ground. So that's actually going to have the same value as the ground because it's the same light angle as the ground is. Then it takes a 90-degree turn up, and then it has a very simple rounded edge. You could call that a beveled edge if you wanted. And then there's another parallel ground plane. So when I do my rendering here, the important thing is, what do these transitions look like? So the value that I start with here on this flat surface is going to need to be the exact same value as the upper parallel surface. Because this object, I'm drawing it as a little bit lighter local value than the actual material of the ground. But the important thing is that within this object, that the pair of like angles, the two top facing surfaces, have the same value. Then I know that the surface that picks up the most light is going to be the edge of that bevel, because that's pointing most tangent to the light source. And then the darkest areas are going to be the ones that are these front-facing surfaces, here and here. So this is essentially a rough block-in of the values. Now it becomes a question of smoothing. How do those planes transition into one another? So on this very gentle, slow curve, I'm going to have a airbrush, super soft, super slow gradation. Now when it hits this corner, it's a 90-degree corner, so it's going to be a very harsh transition. It's going to go from light to dark. No gradation in between. Now up here at this bevel, it's a little bit softer, so I'm going to soften that edge a little bit. And the same deal as it reaches the top plane. So you can see here, I was very intentional about the way that I transition from plane to plane. And in doing so, it gives a very clear representation of a very specific form. You look at this and you know, I can see the shape. So let's go ahead and modify it to look like this. Here we have a transition from hard machined edges into a soft organic shape. It's almost as if we had the previous object made of clay, and then we just sort of rounded out the front. Well, that is going to be sculpting with the way we transition from one value to another. And for this, I'm going to be using the smudge tool, although you could use any method you want. The important thing is being very careful about how I'm choosing to transition from one value to another value. It's amazing how quickly just doing a little bit of smudging between this hard edge, turning it into a soft edge, just transforms the shape. If you were to imagine contours over top of this new object, it would look very different than those previous hard right angles that we had. And really all it took was smudging. And of course, at the end, I'm going to go ahead and put hard edges back around the silhouette, because when you're painting, you don't want to be sloppy. If you have a soft transition, that's fine, but eventually there's probably going to be a hard edge somewhere. So hopefully this makes a very crucial point painfully clear. The way that you treat your edges tells the viewer a lot about the form. It was not a huge difference for me to go from a very hard, mechanical-looking object to a totally organic, soft shape, almost like a stone that was tumbled in a river. So the way you use your media, the way you communicate those edges, is just going to really sell the form. So do not get lazy when it comes to that transition between one plane and another plane. Okay, so speaking of that transition from one plane to another plane, there is often a small bevel or fillet, and a fillet is sort of like the opposite of a bevel, between right angles. Something that you would think of as absolutely a right angle between two surfaces. If you look close enough, it's actually not. And when you have a little angle down here, it's probably going to be pointing pretty tangent to the light source, which means it's probably going to be pretty bright. And this is something often overlooked by beginners. They will think of it as a perfect right angle, and in doing so, will have incorrect values. To make it look more realistic, you might want to include a little hot spot down there where it's catching that light just a little bit. And then the question of how does it transition between those two planes would tell you a little bit about the shape of the profile. Here I started with sort of a hard transition, as if it were a machined bevel, and then I smoothed it a bit to make it smoothed out, almost like a half pipe on a skateboarding ramp. So the point of all this is use the light angle to help you determine relative values. It's not an exact science. All you need to do is make sure that the ones that are the brightest are the ones that are pointing most directly at the light source. And then the next most important thing is where you have two different planes meeting one another, what is the transition? Is it hard or is it soft? So to practice these two things, I've included a variety of profiles, just like the last few examples. And these are in the homework resources folder, and I encourage you to render them. Here you're going to want to be more specific about the brushwork that you're using because, as we showed, the difference between a hard edge and a soft edge really does matter. So I encourage you to take your time with these. This is great practice, even though it's not all that sexy, and it's totally going to increase the realism in your rendering. So I considered whether or not to include this in the series, and ultimately I decided it was important, which is that we've talked a lot about one type of lighting. We've talked about strong directional lighting, which has sharp shadows. Well, if you have different types of lighting, you're going to have different types of cast shadows. Now, this is something that I'm going to go into a lot more detail on in Basic Rendering 3, which is coming soon. But for now, I just want to show the same scene, which is this cube in a simple room, rendered with a few different types of lighting. So the first one we're going to do here is sunlight. Now, in this case, the sun is coming through a window, and so it is not infinitely big. It's almost like I'm casting a shadow, and I use the exact same technique for that. But what I get is the shape of the illuminated sun. And this is going to be the brightest by far light in the scene. And for this imaginary thought experiment, we're going to have no artificial lights in the scene. So what you're imagining here is the light comes in at this very strong angle, and it hits the floor, and then it bounces. And if you remember from geometry class, the way things bounce is as if they were reflected across a mirror. So if we look at it inside view, the light would come in at this angle, and it would then bounce up, and it would illuminate another surface. So the way I would represent that in my rendering is to have sort of a illuminated back wall. And the back wall is going to be brighter than the side wall for this reason. There's also going to be a lot of other random bounces of the light filling up the space, which is going to give me sort of generally soft shadows. And it's really going to fill in that cast shadow that would normally be cast by the cube. But in a very, very simplified way, you can think of sunlight as being a strong beam and then a lot of bounce light. So there's really not going to be dark shadows anywhere. In fact, if you're looking around your house right now, if it's daytime, you'll see this. Open the blinds, let the sun come in. You still have a bright room, even though there's no lights on, but the brightest spot is where that sun contacts with the floor directly. So this next example is as if we had a candle in the room. And the first thing you probably notice is that you have very long cast shadows. Now, the way this works is similar to the way we were casting parallel light rays from the terminator's edge onto the ground plane. Except here, instead of parallel light rays, it's like a starburst. All of the light rays are coming out from a single point, emanating out towards the walls. And so all we need to do is connect those lines to the corners of our forms, and we get these exaggerated long shadows. But really the process is exactly the same. Find the terminator, connect it from the light source through the terminator to the ground plane. It was just a little easier before when all the rays were parallel. In this case, you actually have to pull lines back to the location of the candle. But really, it's pretty straightforward. And so when we do this in our rendering, what we are left with is a cast shadow that's really much larger than the object itself. If you've ever been around a campfire, you've witnessed this in person. Now, light has a fall off if it is an artificial light. It is not as relevant for the sun. What that means is close to the light source, it's going to be bright, and then the further away you get from the light source, it's going to get dimmer and dimmer. So even if you have the exact same angle from the light to the surface, a close object will appear brighter than a far object. So this candle is going to be illuminating in all directions, so it's going to have sort of soft pools of light below it and on the walls, but then definitely a very brightly illuminated front face of that rectangle. As we get further and further away from the light source, it's going to be dimmer and dimmer. And then we're going to have a very pronounced cast shadow, and that's what we projected those lines from in the first place. But as well as getting dimmer and dimmer as you get farther and farther away from the light source, you also get softer and softer shadows. So the way I'll represent that here is by sort of softening up my selection here. And then as I fill it in, you can see that it starts very sharp at the base of the rectangle, and then it gets softer and softer as it's further away from the light source. So I like to think of these as sort of like a burst of energy. They are the very brightest right at the center, and they point out in all directions equally, hit stuff sometimes or don't hit stuff, and then as they get further and further away, it gets dimmer and dimmer. The only trick is that you make sure you are casting your shadows correctly because they are not parallel light rays, so make sure you trace the correct lines. The next type of light I want to talk about is an area light. That's what they call it in 3D software. You might think of it as a big fluorescent light panel, a light box for photography, or really even a window on a cloudy day. It's sort of equally glowing from all different points. And the way we're going to think about that in simple terms is it casts a soft shadow. But the question is, where is the shadow? How do we project it like we've been doing before? The way I like to think about it is think of a single point light, just like the candle. And if you were to project shadows out from it, this is what you'd get. Well, then think about another point light next to it. So here we cast the same shadows in the same way, and we have a sort of different lighting arrangement. Well, let's add those together. When you add them together, you can see there is a bit of an overlap. They both had large cast shadows, but over near the edges, they are sort of filling each other back in. But directly behind our shape, there is still a dark cast shadow. Well, this is the general principle. Instead of a point light like a candle, or parallel rays like the sun, what we have is like a grid of point lights. So here, this rectangular glowing box you can think of as rows and columns of point lights. And like before, if you were to envision what happens when a bunch of these independent point lights overlap, you only have a little area right in the center that remains dark. Well, that's the result. They all overlap, there's a lot of illumination, but where none of them are able to reach, that's where you have shadow. So this just takes a little bit of imagining, but eventually you'll start to be able to see what a large glowing area light would look like. These are very common in interior spaces. If you go to the library or your school, area lights are very common. They make things look nice and friendly, and they have very soft, gentle shadows below them. So the real takeaway here is that the rules I've been explaining for most of this series pertain to a specific sort of light. Now, directional light, in my opinion, is the best way to showcase form. If what you want to do is describe a cool concept art piece, directional light's just a good choice. But as I've shown here, other types of light yield different types of shadows. The form shadow, the cast shadow, they're just going to be different if you have sunlight or a candle or an area light. So if you want to learn more about this, make sure to keep an eye out for Basic Rendering 3, where we'll talk about this and surface materials. But just keep this in mind when you're working from your imagination, that the rules are not always the same. Now in a few minutes in the next video, we are going to do the final example. But before we get there, I I really need to hammer this point home, which is that simple shapes are the gateway to doing complicated shapes. And I don't mean that in an abstract way. What I mean is when I see a complicated shape like this, what I do immediately is imagine it as if it were primitives. Because as you've seen, there's a certain amount of calculation that you have to do to cast shadows and to figure out where your values go. And to do that on a really complex shape is kind of overwhelming. So instead, you have to mentally reduce it into a simple object. And then you have a starting point. But that starting point is only efficient if you're totally comfortable painting these primitive shapes. And that's not something that just sort of happens automatically. What you need to do is practice. So you can see here that I have visible construction lines, and this is pretty common for me because I know I'm going to be painting over top, and so what these help me do is just envision the form. Because if all you have are strict outlines, it can be harder to look at an outline and envision these sort of cross contours. But if you leave yourself some visible construction lines, it just makes the step easier. And this step is really important. This placing the landmark phase is probably the most crucial part of the whole process. Because afterwards, then you've got sort of a coloring book that you fill in with tone. And you know how to fill in tone and you know how to mix edges. It's really just this original blueprint stage that's going to make or break your rendering. So I think about the shadow shape as a graphic. Here I'm really just giving myself a shape to then refine with tones later. But I'll just think of it first as a single tone. Then I go ahead and darken in certain areas and lighten certain areas with reflected light. And then the rest is really just polish. At this point, I will often sort of flatten my document and not worry so much about layer control because now I've got it all in place. I don't have to worry about shifting things around. I'm just sort of making it look nice. In this example, it is crucial that you know where the ground plane is. And if you've watched the linear perspective series, you know that the spot where a ground plane meets a wall is a great place to start projecting from. But once again, this is the important stage. Get these shadow cast projections correct, and the rest will really all just fall into place. Now I'm going to go ahead and fill in the shadow shape as a single tone, and I happen to be using a nice marquee selection here, but you could really select this any way you wanted to. In fact, if you didn't want to paint inside the lines, you could just paint it freehand. Then I'll add a little bit of nuance inside the shadow to represent the bounce light and the occlusion shadows. I'll put in a brighter value for the ground plane, and also the same value for the top of the cylinder, because those have an equal angle relative to the sun direction. The back wall on the scene is much more parallel to the light direction, so it's going to be a little bit darker. And then I've got all my important stuff in place. At this point, it's just polish, soften some edges, and I'm good to go. And this one is exactly the same. I'll start with casting my shadows, and then once I've got my shadow shapes figured out, I'll lay in some flat tones, put in a brighter tone for the faces that are most tangent to the light source. In this case, it's the ground plane and the tops of the objects. And then I polish it out. So hopefully you can see here that this just takes practice. You're training your brain to recognize certain forms. You're understanding what a cylinder does. You're understanding what a cone does, which will allow you to mentally combine them together and just help you simplify more complicated forms. Now, in all these examples so far, I have been pretty rigid about the steps. You begin by casting shadows and then you lay in a flat tone. Well, that's not the way I always work. I've really sort of laid it out this way to make it clear for your benefit, because when you're learning this stuff, it's nice to have structure. But what this is all getting towards is sort of a mental shorthand. Once you've done this enough times, you just start to internalize it in a way where you don't need to follow the exact same process. As you'll see in the next demo, I jump around a little bit. And the reason I'm able to do that is because I can look at the line drawing, look at the light direction, and just sort of imagine what the shadows look like. And the reason you do boring studies like these with the basic primitives is to allow you to be able to freehand the more fun stuff. So you can't get there for free. You have to do these boring basic shapes. But every one you do is going to build those muscles. So then when it comes to drawing something more exciting, you're ready. So now that you've seen all the secrets, hopefully this will seem a little less intimidating. Yes, it is a very complicated shape, but really I'm just going to do the same few things over and over. So let's go through how I would approach a truck like this. First off, I need to know the direction of the light, which I have here, and I've also indicated the ground plane. So the first thing I might just think about is, what if this were a very, very simple shape? What would the general planes look like? And that would give me kind of a nice starting point. I might use this and save it out as reference. But at some point, the next milestone I'm going to need to get to is the terminator. So before we were doing pretty simple objects, each one had a terminator, and then that allowed us to cast shadows. Well, here there's a bunch of smaller forms, but each one is going to have the exact same setup. Each one's going to have its own terminator, which is where the form becomes parallel to the light source. And if I can start by creating all those terminators and casting shadows, it'll be no problem. So as you can see here, I'm actually deviating a little bit because I'm painting this the way I would actually work. So in that case, what I'm doing is imagining where the Terminator is and casting shadows. Now, that just comes from me spending a lot of time doing this. I've just had a lot of practice, so I skip around a little bit when I work. But I could not get to this place if I couldn't imagine where those Terminators were. And also from a technical standpoint, I've actually separated these railings from the rest of the truck, which means here I'm painting and I don't have to worry about painting on top of the railings. But as you can see, I just go form by form and I'm casting shadows, and the shadows are going to be based on where is that Terminator. So I'm not thinking at all about the full value range at this point. I'm just thinking about where does the shadow shape start and where is the shadow being cast. And I do that over every form in the object. It's not really all that challenging once you get the hang of it. It's just time consuming. You know, the secret is, once you get to this point, this is a lot like basic rendering 1. Yes, we were rendering a vase, and a vase is a lot more simple than a truck like this, but it's the exact same process. You're making a shadow shape in an illuminated form, and then you're just rendering it out. So my next step is going to be to add in the form shadows. These are going to be my soft shadows that help kind of round out the form. And generally speaking, these are done with a much bigger brush. I like to use airbrushes for this. And once you have those hard edge cast shadows in place, this step becomes really pretty simple. I just have to keep in mind where is the light coming from and what's the general value arrangement going to be. And from there, I just sort of fill in the form shadows. And then it's just a question of adding in shadow detail. So I haven't really talked about it too much in this series, but you'll remember from basic rendering 1 the idea of occlusion shadows. That's where there's sort of dark pools of shadow in the crevices of the form, because bounce light is not able to bounce in there and lighten it back up. So once again, here I will just focus on the areas that are in the shadow shape, and I'll just darken in those crevices. And I do the same principle across the entire model. Once again, not challenging, just time consuming. Now you might wonder at this point, why is there no cast shadow underneath the truck? Arguably, I should have done that first. Once I'd found all my Terminators and began casting shadows, it's really a good idea to put in the major cast shadow of the form. It just helps ground an object. But because I wasn't really thinking too carefully when I made this example, I saved it for last. But the principle is exactly the same. I'm going to be projecting lines parallel to the light direction from the edges of the form until it intersects with the ground plane. Do this enough times and you have the shape of the shadow. Now here I'm kind of eyeballing it because, again, I've had a lot of practice with this, but the principle doesn't change. And since this is a sunlit scene, I'm going to have a pretty hard edge shadow, which I'll fill in with a pretty flat tone. And then I'll erase away where I don't need it, and there I've got my cast shadow. And once I've got all my major values in place, now it's just tweaking. So here I might use the levels adjustment to change the overall value arrangement. And then you start polishing. Then you continue polishing, and you keep polishing. Well, you know how it goes. You try and get rid of those lines, incorporate it into your painting, so you end up with something that just looks smoother. And this is exactly like we did in basic Photoshop rendering. It's just time consuming. But eventually you'll get to something that looks like this. And then I could take it a step further to change the local value of these objects. So here you can see that I applied the same rendering model to all the different shapes. But then some objects are going to be painted black, some might be gray, some might be white, and as a result, they're going to have sort of a overall value shift. But from a shadow casting standpoint, you saw how I approached them all in the exact same way. So hopefully you can see that the truck here is not an impossible leap from our spheres and rectangles. I know I've said this 1,000 times on the site at this point, but work from simple to complex. It's not going to be easy to open the line work I've included for this truck and to just paint it right off the bat. I can't encourage strongly enough, do the homeworks. Work with basic primitives. If you can really nail imaginary lighting on basic primitives, the leap to doing a truck like this one's going to be a lot easier. But if you just sort of theoretically understand how it works, you watched me do it and you kind of get it, you're not ready to do a complicated object. So start slow and then add more and more complicated objects once you feel comfortable. And once you're good at basic matte surface rendering from your imagination, you're going to be ready for the next video in the series, which is Basic Rendering 3, where we'll talk about complicated surface materials and different types of lighting. So stay tuned for that in the Ctrl Paint store. And once again, thank you so much for supporting the site. It's a big deal. You're allowing me to keep making free videos for the library, which I think is incredibly important. And each of these videos that somebody buys allows me to keep this project going. So thanks for the help. And if you've got friends that might like digital painting, tell them about the site. Have fun painting, guys.